like a low voltage using
Sure.
a MOSFET,
Mm-hmm.
NPN transistor or NPN MOSFET. But then does that NPN MOSFET only control a high side load? I mean, a low side load?
Yes, it is.
It can't do high side load.
No.
Okay. So we'll need to use a PNP for a high side load.
Yes. Which course?
Switch course?
No. What is the course? The course number for this project?
Oh, it was just in-home. It was just me playing with. I got some transistors. So I was just playing with transistors.
Oh, okay. It's like your own project. Okay.
Yeah.
I like your own projects. If you guys let me know that you're interested in doing research, I can add you.
Oh, awesome.
My research. I work with NASA for a project, and I work also for the U.S. Air Force. So.
Oh, I was just trying to figure out the theory behind the reasoning why the PNP transistor, or sorry, NPN transistor does not work with a high side load.
Nah, that's really easy peasy. I'm building something new these days. I'm building a smart warming and cooling down cup.
Cool.
For elderly people. So that's also I need people to work with me on that, which is allied to the whatever circuit you are doing, because the circuit I need to do, it's gonna be a temperature regulator. So then I can send from my phone an order to the cup to where to get warm or to get cold. It depends on whatever I want to do. It's not made for regular people. That's made for the elderly people who doesn't know how to use microwave and stuff like that.
Cool.
Anyway, let's see what we're gonna do today. There is a bunch of other projects, but just let me know if you want to join any project and we'll do it.
I think it'll be easier once we go on campus and see what kind of projects that you're working on.
Yeah, have you guys heard about this Raspberry? It's called Pico.
Isn't that like a measurement?
The new
it is a $1. I was like, what the heck? It's a $1 chip.
You're talking about the RP 2040?
Yes, it's called Raspberry Pi.
Pico, yeah.
Pico.
It's like $4.
It's like $1.25.
Yeah, they're cheap.
It's basically using the mini Python in a way that you can program it, and then you already you can set a headers, and then you can put it on the top of the drone. You can put it for like sending and receiving data to your phone, whatever.
No, it's super awesome because it supports micro, but it also supports assembly. So
yes.
And it's a RISC-V architecture. So
it is RISC-V architecture, exactly.
Yeah, so you can do whatever you want with it.
Yes. This one, I went to Micro Center yesterday and I didn't find it. People I wanted to buy like 100.
I bought 5 of them. The ones from Tucson. I bought like 5 of them from the place in Tucson. I basically, when it came out, I just bought as many as I could. My friend's holding on to them right now for me.
Oh, that's very cool. Yeah. I mean, I went yesterday to Micro Center and they told me, no way, we got it, and then a few days, like 1 or 2 days, and we are out of stock. I was like, what? That's not cool. And it is what it is. Stuff like that I would recommend you to play with. That's basically what I can recommend you to do, because end of the day, this is the real job. Anyway. Back to the future. So let's talk about our course, the new topic, and then we can even talk more about some problems to solve and so on. Okay. So last time we talked about using the postulates and whatever properties the Boolean algebra can give us. And I saw somebody actually from you guys on the Slack appreciated actually his movement, and he added like a table, very nice table, showing the relation if you have like an A as a variable and an OR with 0 and 1 and stuff like that. This is stuff really appreciated. So anybody has something he found in internet and he like to share with us, just add it there. That's really cool. And I think Noah also add something about his code that have been developed for the numerical conversion, right? I think so. So you have you guys are really creative. So add more and more there. That will open more opportunities for you. Also, I'm not sure if you heard about a program. It's called Rayo here in Capoli. So, you know, they fund your research, undergrad research. So they pay you like a year funding or something like that, like a 2 semesters. Look at it. I will, if I find the email, I will send it to you. It's called Rayo, R-I-O. Okay. And there was another one. It's called R-E-U. And, you know, actually, this is the season for applying. So search in Calpoli website and look up for those two guys and let me know if you are interested to do anything with me. I can do it with you. It's no problem, you know, and you will be paid. Anyway, so now we learned before about the logics, and we learned about 3 different type of logics, and we said it's an OR and an and NOT gate, right? And we also learned something is called truth table, right? Truth table, which is a table used to describe the relation between the input and outputs. And since we are in we are using we are using binary as our primary system, so a number system. So end of the day, number of variables will define how many states this table will be covering, right? In a relation saying 2 power of the number of variables, right? And we already know that in the Boolean algebra, the operator, this is called AND adding is no more adding for us, is basically called OR. And then, you know, the negation will be not, right? And we discussed this many times. Now we are gonna talk about something is called canonical and the standard forms. So what is this? There is something is called MINterm, and there is something else is called MAXterms. MINterms, MAXterms. What does those guys are? So let's talk about them. So if you guys remember, we mentioned that, for instance, for AND gate as a 2 input variable. So like, let's say f and a function of x and y is equivalent to the as an AND. It's gonna be a b. Oh, sorry, xy. Let me admit Liam. Okay, and we said if it's an OR, f x y, it's gonna be x ORed with y, right? And when we build the table, we build the table in a way that's saying for the x and y and f and a function of x and y for the OR, how many states we're gonna have? We're gonna cover 4 states, right? And they're gonna be 0, 1, 0, 1, 0, 0, 1, 1. And we said they're gonna be 0, 1, 1, 1, right? So imagine this one is called MINterm. Every single state here is representing MINterm. What is this? The MINterm, the term itself, it has to be 1. So the term has to be represented in 1. And you have to end it. So what does it mean? So, you know, that's called M0. That's called M1, M2, M3. So we are using the lowercase to represent the MINterm. Okay? So this table is representing how many MINterms? 4 MINterms. Okay? Let's look at the MINterm itself. So the MINterm M0 is what? It's a combination between the inputs x and y to present M0 as an 1. So I have an x is equal 0 in this case, and I have an y equal 0 in this case. So the only way to do it, to make it 1, is to do what? To say x complement ended with y complement. Again, this is x is equal 0, y is equal 0. Do you agree? So I want my MINterm end of the day to be equal what? 1. Okay? So this table...
Sorry, Professor, and the operation is always AND?
Yes, for MINterms.
Okay, got it. Thank you.
MAXterms, we're going to say the MAXterm is the complement of the MINterm. Okay? So anyway, now back to the point. So If I want to rewrite this table, I'm gonna write it like this. 1, 2, 3, 4. M0, M1, M2, M3. Right? X, Y, 0, 0. Right? I want to write the MINterms. So the MINterms, I'm going to write it here to be what? X complement, Y complement. Here are going to be X, Y complement. They're going to be, no.
Sorry, it wasn't going to be X pop.
I'm sorry, here. Can you see what I'm doing? Now going to be X, Y complement. Here going to be X, Y. So a table combined two variables as an input will provide me 4 MINterms, and those 4 MINterms will be sorted as we can see in front of us. Output is different story. Output is different what story? Because the output for me is a relation. So out between the input and output. So output here, X and Y, right? It's covering OR gate, right? So if I'm looking to OR gate, so basically this term is 0. This term is 1. This term is 1. This term is 1. Okay? Any questions so far regarding this part? Anyway, now let's look at this, okay? We already defined the term using AND. What about if I would like to define relation between the terms? So for instance, if as a function of X and Y, it's a summation or ORing of the MINterms are valid by 1. What does it mean? It means the following. It means fxy, it's a kind of combination between M0 or M1 or M2 or M3. So those 4 terms are a part of the decision of what is fxy look like. Okay? So we can write it like this. I equals 0, 2, 3, because you know here M0, M1, M2, M3, and this is what? Mi. So far so good? Now, if I start looking to my table, I will find out there is one only term is giving me what? It's giving me what? 0. This one. Do you agree? So end of the day, this one I can exclude. Useless to me, right? So I can really literally write that, you know, this is equal to M1 or M2 or M3. Those 3 guys are the one is representing to me the 1, making the f as a function reducing 1. So if M1 is exist, it will give me 1, or M2 is exist, it will give me 1, or M3 is exist, it will give me 1. If all of them exist, it will give me 1, which is will not happen. Okay? So anyway, if I look at this and break it up from the equation in front of you, look, M1. I'm going to take M1 now. Where is M1 in front of me? M1 is this one, right? So it's going to be X complement Y. Or M2 is what? X, Y complement. Then M3 is what? X, Y. Right? Those are the 3 things. But, you know, Professor Ali said, you know, this is OR gate, which is basically X ORed with Y, right? But this is not X ORed with Y. So what should we do? We're going to apply the postulates to make what? Minimization. Right? So if you look to this function, how I'm going to minimize? Somebody can tell me, what should I do?
Pull out the x's in the last 2 terms.
Exactly. So let me see, somebody's getting in. So basically this guys together, we're going to bring me X, right? If you guys remember, because they're going to be X ended with Y ORed with Y complement, right? And this, if you guys remember, is equal what? 1. So basically this is X complement Y. I'm right? Let's check here. So this is what Y. We took this here, right? So this is 1. So based on the duality, this is equal XY. Let's see how. I have a line is X. And this line is ORed with a combination of the end of the X complement and Y. Right? So, end of the day, if I put here X equal 1, right? X here, it will equal what? Huh? If I put here X equal 1, X complement it will equal what? 0, right? Anything ended to 0 based on the table that you know on the Slack, what is the output should be? 0, right? Huh. The output will be, if I OR 1 and 0, it will be 1. So yes, if X's exist with 1, that will affect on the output to be 1. You agree? Now, if X is equal 0, right? So if I put here 0, so this branch is equal 0, right? So the only way to make this combination equal 1, if this guy will give me 1. Do you agree? So that means Y it has to be coming into the equation. So that means this combination will be also equal 1 if Y is exist with equal 1. So that means, you know, X or Y should be equal 1. So that's why, you know, this thing, it can be replaced by that thing. Make sense? Does it make sense? Hello? If it doesn't make sense, let me know. If it makes sense, let me know.
Yes, it does. Thank you.
Yes, $5 because it makes sense. Yeah, you can pay $5. Maybe coffee. I don't know. Anyway.
Coffee sounds good.
Yes. No, I'm just joking. Anyway, now you know what we learned so far. We learned that, you know, the truth table is a what? Is a bunch of what? MINterms. And the relation between the MINterms are what? Controlled by what? OR gate. So every single MINterm, it will be what? It will be using AND, but, you know, adding them together are going to be OR. So again, let's make another example. Let's imagine that I'm trying to build an adder, something, 3 variables. Let's make it 3 variables like this. X, Y, Z. And I'm trying to add the 3 of them together. I'm trying to add them together. One second. Okay. Let's add them together. So 3 variables, how many outputs I should have? Somebody tell me.
9.
Huh?
8.
8. You're right. So we're gonna be 1, 2, 3, 4, 5, 6, 7, 8. Right? So gonna be here 0, 1, 0, 1, 0, 1, 0, 1, 1, 2, 1, 1, 1, 2, 1, 1, 1, 2, 3, 4, 1, 2, 3, 4. This table this time has how many MINterms? 8. M0, M1, M2, M3, M4, M5, M6, M7. Okay. Now, what should I do with this table? What do you guys think? Do you like to do what circuit? Do you want to make it add and add and subtract, or do you want to do whatever? Let's make an example of like, majority. So I'm looking for majority 1. If I see majority per state 1, I will donate. I will donate it F as an 1. So what does it mean? I have 3 variables. I'm looking for every state. If I see ones are the majority, I will put 1. So let's see. State number 1, M0. How many ones I have?
None.
None, 0. State number 2, I have 1, but I have 2 zeros. Who is winning?
The
0.
zeros.
State number 3, I have 2 zeros playing in front of 1. So basically still winning. Then state number 3, 2 ones versus 0. So it's winning. Then state number 4, 1 versus 2, 0. State number 5, 2 versus 0, 1 and 0, gonna be 1. State number 6, 2 versus 0, 1. State number 7, 3 ones, majority, 1. So what I did in front of you now, I give you an example of a circuit we are trying to build. And this circuit is like this, a box. It has 3 input, and this input X, Y, Z, and the output is called F, X, Y, Z as a function, right? And what it does exactly what we already discussed. Do you agree?
Yes. So now we gotta figure out the function.
Now we're gonna figure out the function using what? MINterms. We use what? MINterms.
Cool.
So again, let's define again MINterms. MINterms are the term is causing the function to equal 1. MINterm is causing the function to equal 1. So this means that if I have tables, the relation between these states inside the table are ORed. So that means, if X, Y, Z is equal, the summation, which is an OR, I equals 0 to 7. Because see, M0 to 7. And here M7, sorry, MI. Because, it's like adding, right? Anyway, now, who is causing this function to equal 1? M3. M5 and 6 and 7. You guys agree? So M3, M5, and M6 and M7. Okay, let's now write them. So M3 is what? It's gonna be X complement YZ, right? So it's gonna be X complement YZ. Y is 1 in Y. Z is 1 in Z. X complement, that means X, if it's 1, that means it's flipped, right? So it's Z, you understand what I'm saying? Okay, anyway, now OR. M5 is what? Somebody tell me what M5 it should be.
X, Y complement Z.
X, Y complement Z. You are right. So somebody else give me M6.
X, Y complement Z.
X, Y complement Z. X, Y complement Z. Somebody give me 7.
XYZ.
XYZ. So those are the function coming from the multiple MINterms related to each other. So this term by itself can cause this function to equal 1. This term by itself can cause this function to equal 1. Excuse me. This one is causes the function to equal 1. This causes the function equal 1. Now we need to apply what our optimization we learn about the Boolean algebra and relation between what stuff, right? You guys agree? So we can look at it. Somebody can help me. What should I do? What do you think about this and this?
Factor out the XY.
So Z will be out, right?
Right.
So let's take Z out. So gonna be here X, Y, and then these two guys, who can get out, who cannot get out? Is there a way to do it?
Z can.
Yeah, you can just do Z like this, and then you can take it X complement Y. Later on, we know this is actually a logic. But we didn't take it yet. We just take the or and not, right? Anyway, so everybody now understand what does it mean MINterms? Did you know how MINterms can be used?
Wait, Professor, was
Yes,
the
sir.
first term x complement y complement? Oh, yeah. Is it? No, wait. We're looking at M3, right?
X complement y z.
Yeah, it should. But on the equation, you put z complement.
Where?
Oh no, wait. Sorry.
Where?
Sorry. No, my mistake.
$5 fees. Okay. Sounds good. Now we need to know what is the other guy called MAXterm. What is this MAXterm? So MAXterm is the reverse of MINterm. So the term is causing the whole thing to equal 0. So who is actually the gate is helping me to make everything equal 0? And, right? So we're gonna flip the players. So the or will be in the term and the products will be in the function. So again, so max term. So we need the max term to be the this is a sum. This is a sum. It's basically presenting the or. They're gonna be like this. Product I0 to 7 MI. Sounds
So
good?
is that a summation? Or is that pi?
Summation, the or will go into the term. I will show you. Anyway, okay. So imagine the following. M0, it was what? It was x complement y complement, right? Now I need to bring the max term of it. How can I do it? So basically M0 is equal to the M0 complement. Somebody is asking what is the max formula? Here's the formula. Can you see it?
What's that letter in between 7?
This one? Product. Yeah. So, this is the sum, this is the product.
Oh, interesting.
Math. You don't like math? But math like you. Anyway, so let's go ahead the part. So now you already have M0, and here is the max term of it. So the max term is a complement of the MINterm. Let's see how it look like, right? So basically this is equal to complement of it's going to be x complement Captain De Morgan. Where is Captain De Morgan? So Captain De Morgan told you what? Break the complement between the players in the term, right? So that meaning going to be x complement. That and will be or, and y complement. So pretty much you can write it to be x or y. So if x is equal 0 and y is equal 0, that means this term is equal what? 0. So we succeed. Yes, this term, it has to be 0. Does make any sense? Okay, so we can actually rewrite this table again to be max terms. Let's do it. So here, I need what? M0, M1, M2, M3, M4, M5, M6, M7. So let's play. Now, this guy was like everything products, right? Or and it. So if I want to do it, it's going to be X or Y or Z, right? Any of them can cause the whole thing to be equal 0. Then, let's go to the other one. So it's going to be X or Y. And because Z is 1, I want to flip it to make it actually 0. So it's going to be Z complement. Then, if I go to the M2, Y is actually the troublemaker. So gonna be X, Y complement Z. M3, it's gonna be both Y and Z. It has to be complemented so I can be sure the term will equal 0, right? So gonna be here X, Y complement, Z complement. M4, X is equal 1. The 1 is actually has to be flipped. So gonna be X complement, Y, Z. And M5, is basically 1, 0, 1. So basically x and z, it has to be flipped. So going to be x complement y, z complement. M6 is going to be x and y, the one need to be flipped. So going to be x complement, y complement, z. And M7, all of them has to be flipped to be sure that it equal 0. So going to be x, y, z, complement, complement, complement. Does it make sense to everybody? Hello.
Yes.
Okay. So if I want to write the function can cause this thing to equal 0, basically I will look to those guys. All right. So those are the one in the function causing 0, right? To make f equal 0, correct? So I can write f using the max term equal to the why I do this all the time? Yeah, scheiße. Is equal what? Who's causing 0? M0, M1, M2, M4. M0, M1, M2, M4, right? M0 ended with M1, ended with M2, and M4. So far, so good. Does it make any sense to everybody?
Yeah.
Super. So, of course, if you play with multiplying them and all things, if you actually make complement end of the day, it will flip to the other one MINterm, right? You understand what I'm saying or not? So if you have a MINterm, M0, it was X or like this, right? If I want the MINterm out of this MAXterm, what should I do? It will be M0 equal to M0 complement. It's duality thing, you know, you move from here to there, here to there. Because why actually we are doing this? Because you know it's a binary, 0, 1. So either way, right? There is power, there is no power, there is volt, there is no volt, and so on. You know what I mean? So in that case, I can come and say X, Y, Z complement is equal to X complement and Y complement, Z complement, which is exactly the same thing we got about the MINterm. So we understand now what is the difference between MINterm and MAXterm and how it works and how it affects on the function. You guys agree? Everybody agree? If you don't agree,
If you're choosing which one to use to find a function, would you just go with whatever, you know, if you have more zeros, use max. If you have more ones, use
most likely we go with MINterm.
Oh, okay.
You know, everything else in the world gonna be MINterm and gonna use optimization and stuff like that. But
Okay.
maybe, you know, this is just a practice to show you what is the difference between both of them. Maybe it's in a complication way that you need to make a MAXterm. Like, you know, basically you're gonna build the whole entire function and then you will put here not gate at the end. Make it much better and more efficient.
Would it be possible to see this in an example?
Yes, here. Right? That makes sense? This is an example. Do you want one more example?
Sure.
Sure. Let me find you example. So, X, Y.
Well, the example that you did was just like the majority, right? That's what you called it.
Yeah,
So,
I just called majority encoder. Basically, it's encoder. It's encoding.
Got it.
But I mean, I don't want to put too much on the top of your head now. You're just learning rules. Later on, you're gonna learn to design. You know what I mean?
Got it. Thank you.
But anyway, let me just make you some weird example. 1 second. So X, Y, 1, 2, 3, 4. Let's make it like this. It's a function, by the way. This is a function, but I'm not gonna talk about it now until you know we understand. So let's do with the MINterm. Somebody can tell me what is the MINterm out of this? So gonna be a function of X, Y equivalent to I equals 0 to m equals 3 because I have m0, m1, m2, m3. Do you agree? Where is the terms are causing me equal 1? This guy and this guy, right? So pretty much is mi, that means it's going to be m1, m2. Do you agree? So equivalency. So m1 is basically what? Huh? Who's going to give me
M1,
one?
it should be M1 plus M3.
M3. You're right. Go ahead. They're going to be
It should
what?
be XY.
Yes. Now, if I would like to write this in the max, what should I do? It's going to be f xy is basically m product I equals 0 to 3 I. So where exactly the terms are causing me to be 0? This one and this one. Do you agree? So going to be m. So going to be m0, m1, right? No, m0, m2, I'm sorry. Right? Where is m0? Huh? M0 is what? Somebody can tell me how it looked like in the max. It's going to be x. Right? And the other one is m2. M2 is going to be x complement or it was y, right? X complement or it was y. Let's multiply it together. So going to be what? It's going to be x complement y. And then, going to be y. Right? So this guy is what? Out. Do you guys agree? So then what else we have? Let me see what I did here. I think I made a mistake. So 1 second. M2 is what? It's x complement y, yes. M0, it's xy, right? So this is gonna be here, right? And yes. So this equals 0, right? So gonna be what? It's gonna be x, y, x complement y, y. Right? So pretty much you can take this x, y, 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 y. You can take this and this. It's gonna be x. Right? That makes sense? Then we did this before, right? It was x or y, right? So it was x. Now it makes sense? So that means, this or this can cause it to equal what? 0. Kiduk, any questions? Hello?
Sorry, Professor, but if you put this on the gate, then wouldn't the M1 equal to 1 as well? Because it says x or y, right? That's the function that you got.
Maybe you made a mistake here. Let me see.
I think the function should end up just y.
It should be y, yeah. So wait a second. So gonna be here ORed.
Yeah, it should be just y.
Wait a second, 1 second. And then where's the other one? M2, right? This one, right? So x complement y, like this, right?
Mm-hmm.
So that's gonna be x complement x and x complement y, right? And
can you remove the y? Oh, sorry. Yeah, it's that'll be x y complement. Oh, sorry, y. Yeah, and then y.
yeah, I mean that should be fine, right? So
Yeah, so in the equation, can you just take out the y for the last three?
Oh yeah, right. I can take completely the y here. All right. Why? No, I cannot. Why? If you take the y out, it doesn't make any sense, right?
Well, you get x complement or x or 1, right? So it would
I mean, those can be
be
1.
1.
Those can be y.
The y could be 1, right?
That can be y.
That can be y.
Hmm? Right? Think about it. Here, look. Right?
Oh yeah, that would be 0 and y, yeah, And then you take out the y on the next one. So yeah, yeah, that's 0, and then the y and y is y, so it will be just y, right?
So why this happened? Let me see. So it's y, the one is causing this to be 0? That doesn't make any sense.
Because if y is 0, then that's 0. The output is 0.
Let me see.
Even though if it's x is 1.
This is what? Let me think about it. This equation of what?
It comes out the same if you use the MINterms too, and then that's only one simplification you have to do.
You mean here?
The x complement and y. If you simplify that, it just comes out to y also.
Let me see. Peter, 1 second. So let's do it. So gonna be x complement and y, and then x, y, and then you order, right? Okay, so if you put x is equal 0, what will happen? 0 is out, 1, then you have to wait for y, right? So you have to wait for y. The y will decide. If x is equal 1, y decide. If x is equal 0, this will go here, y will decide. Yeah, it's gonna be y. Yes, you're right. It's gonna be y. So both of them give y. It shouldn't be. It should be y and y complement. Because this one is reverse the other one, right? Something is not right.
Oh yeah, so the min should be y, and then the max should be y complement.
It should be the flip of it. Basically, how to say? No, it should give you the same. Yes, it should give you the same.
Oh, it should give you the same. Got it.
Because at the end of the day, it's solving the same problem. So yes.
You're just using that to find what the function was originally.
Yes. This is how can you end up? Yes. So you give you the same. So yeah, give you the same. That's correct. Okay. So it's y, you are right, and this one is also y. Yes, this is actually end up to be y. Yeah, so it's correct. Because using few terms, using these two terms are gonna bring y. If you use MAXterm, and these two guys also will give you y, but in MINterms. Yes. Anyway, makes sense? Hello?
Yes.
If I have more, maybe you know what we can do. We finish this chapter and then I can give you one lecture solving problems. That makes sense? We can solve more problems. Okay, let me find something else I need to mention to you guys. One second. Anyway, there is something else is called sum of product, and there is another one is called product of sum. Sum of product and product of sum. It is basically the MINterm MAXterms, right? Do you guys agree? So why? Because it's called sum of product. Which one is the sum of products? MINterms.
MINterms.
Yes. Product of sum is the max term. So imagine the following. If x, y is equivalent to x, y, z. Sorry, z. And I'm telling you, give me the sum of products. What are we going to do? This equation is not giving me the sum of product. I have to do some tricks to make it sum of products. Do you guys agree? So what is this? What is basically I have to do? I have to be sure every single term is representing all different type of what variables I have, right? So this term is representing y and z, but it doesn't have x. Do you guys agree? This term, it has x, it doesn't have y and z. So what I'm gonna do, I'm gonna use my knowledge of the x ORed with x complement is equal 1, and y ORed with y complement is equal 1, and z ORed with z complement is equal 1. So let's do it. So gonna be here, this is missing how many terms? Missing y and z, right? So I can just write it like an x ended with the y complement, z complement.
Professor,
Yes.
what is that letter right next to the y on the f of x, y? Is that a G or?
What? No, this comma, z.
Oh, it's a comma Z.
Okay. So anyway, now this is 1 and this is 1. But at least every single term have everything, right? For this part, y and z, it's actually y, z, and then x complement. Right? So pretty much I can start breaking it. So gonna be what? It's gonna be x, y, z, and the other one is gonna be x, y, z complement, and then it's gonna be let's see what I did here. It's gonna be x, y, z complement, right? And then there we're gonna be what? It's gonna be x complement z, x complement z complement, right? Then I break the other one. It's gonna be y, z, x, y, z, x complement, right? Can you guys check? See if I made a mistake? Yes.
On the third and fourth terms, are those y complements?
Wait.
Complements?
This is a complement, right? So let's see. X, Y, Z, X, Y, Z, X, Y, Z complement, X, Y, Z complement. Then X, Y.
Okay, I was just checking. Those are
No, you're right.
Okay.
Right? X, Y, Z, X. This is Y, right? So X, Y complement Z, X, Y complement Z complement. Right? Then there Y, Z, X. Y, Z, X complement. Yes, we finished, right? Now we just need to see what does actually look like each other to take it out, right? So this term is equivalent to this term. Like X ORed with X. What is the value? It's going to be X, right? So I can actually replace this to be Y, Z, X. Right? Then I look at the other one. This one, X, Y, Z, we don't have it, right? So it's gonna be X, Y, Z complement. Then this one, X, Y complement Z, X, Y complement Z. Then this one, Y, Z, X complement. Then this one, X, Y complement, Z complement. What I did now, I already have what? Products, sum of products. So what I did now is called sum of products. I can actually call those are MINterms, right? So what MINterms we are talking about? If I actually consider X is the from the most significant, Y, Z like this, I can start rewrite, right? So basically I can just write it like this to be X, Y, Z. I be sure that X in the side, so gonna be here X, Y, Z complement. There X, Y complement Z, then x complement y z, then x y complement z complement. So I can come and say this function x y z, it's a function 7, right? And the product is going to be m what? This is what, m7, and this is going to be 110, m6, and this one will be 101, so m5, and this one is 011, right? So m3, and this one is 100, m4. So I can write and come and say that it's gonna be what? It's a summation of m3, m4, m5, m6, m7. That makes sense? Hello? Did you guys follow what I already have done? Hello?
Sorry, I'm just wrapping my head around. Can you go back up a little bit? Just where you did the no. Oh, so you just did the truth table, and then you just
I didn't
did
make any
the
truth table. Where is
yeah.
the
You
truth table?
well, you did the truth table in your head, right?
You don't need the truth table even in my head. Basically, I give you a function, and this function is optimized. So this is optimized, right?
No. So how did you know it was M7, M3? Sorry, can you go back down again?
I did my truth table in my head. Yes. Yes. You're right.
Right?
Yes.
Yeah. Okay.
Without even knowing, I will tell you. Wait. Let's go one by one. X, Y, Z, and we are
You went super fast there.
I know. No. Wait. 1, 1, 1. We heard that MINterm. It has to be what? Equal 1. Do you agree?
One. Yes.
Right.
Yeah.
So look, 1, 1, 1 is what? 7. Here, 1, 1, 0. This is what? 6. Here, 1, 0, 1, 5. There, that's 0, 1, 1. Here is 1, 0, 0. Do you agree?
Yes, that makes sense. Yeah. Okay. Yeah, you just like skimmed through that part, and I was like, oh, that was really fast. But yeah, the truth table was in your head. Got it.
Yes, somewhere in the 5th dimension. Anyway.
Yeah, got it.
Professor,
any questions so far?
Professor?
Yes.
I mean, is the way of writing the truth table like a standard? Because you're having this idea of what a truth table is looking at. I'm having M3, M4, M5. But if I did my truth table in a different order, then my M are gonna be different, right? Or it has to be, or it's okay for it to be in a different order.
It's up to you, but you have to stick with the order till the end, right?
Yes.
So if you would like to put X, Y, Z, that's fine. If you want it to be Y, X, Z, that's fine.
No.
If you put it Z, X, Y, it's fine. But you have to stick from the beginning to the end.
No, I'm not talking about the X, Y, Z. I'm talking about the truth table, the different.
No, the truth table has to start from 0 to the end of the states, right?
Oh, okay.
You understand my point? You have to be M0 to MN.
Yes, but my M0 can be, let's say my M0 is 0, 0, 0, right? And my M1 is like 1, 0, 0. Somebody else can have his M1 to be 0, 1, 0. No, that's not, it shouldn't, okay.
Okay, question, Alejandro. Professor, can you just go over the first step? What do you once have the equation? Was this, yeah, it's called sum of products. Have you noticed? It's sum of products. It's basically here, sum of product. Every single one is a product, right? So this a product, right? This is a product, this is a product, this is a product, this is a product, and I sum them. So that's actually what sum of products. Product of sum is what? Any single item gonna cost 0. So this time you're gonna what? Put X complement and it together. So basically it's a reverse of the sum of product. So product of sum is different than the sum of product by just applying what? De Morgan. Do you understand what I'm saying, Alejandro?
I think sum of products seems to be much easier.
Yes, exactly. I mean, no, it's practical. Basically, you know what we are doing? We are reverse engineering something you optimized, and you are turning backward to the table, the twist table. The twist table is not optimized, right? Twist table is just covering the relation between input and output. Then you apply optimization. The sum of product is a way to reverse engineer to turn it back to the table.
So yeah. So you're making it more with more gates or more difficulty portion
It's
of it.
not difficulty. It's basically, you know, if somebody give you this equation, I will tell you, where's the equation? We have this equation here. Somebody's telling you x, y, z like this, and it's telling you write that twist table for this. So what is the best way to do it? You're gonna apply x equals 0 and y equals 0 and z equals 0, and you start filling step by step by hand. Do you agree?
Yes.
The other way to do it is like this. So you do it what? Using the algebraic Boolean functions. Make sense? Hello? Hello? So, you know, end of the day, I can come here and say that, you know, my truth table describing between x and y and z is like this: x, y, z. 1, 2, 3, 4, 5, 6, 7, 8. M0, M1, M2, M3, M4, M5, M6, M7, right? 0, 1, 0, 1, 1, 1, 0, 0, 1, 1, 1, 2, 3, 4, 1, 2, 3, 4, right? If I would like to write the function now, I don't need to go into the function and start applying, oh, when x is equal 0, y is equal 0, what will happen, right? I would look to this. This is telling you M3 is equal 1, M4 is equal 1, M5 is equal 1, M6 is equal 1, M7 is equal 1, 0, 0, 0. So I just got the table. Make sense? Any questions so far regarding this part? Any questions? Hello?
No, I'm good.
Okay, now if I like to look to the implementation, just like a philosophy of how the product of sum and sum of product look like, right? We said what? We said sum of products. Do you agree? So sum of products. So here's products, here's products, here's products, and I'm summing them. This is and this is or. So sum of products. So the element that's giving me product is what? And. The element is giving me sum is or. What about product of sum? Product of sum. So product of sum. So gonna be and like this, and every single term is gonna be or. Sounds good? Any question?
Nope.
So if we finished, maybe we can stop here today and we can continue next time with more examples. So any questions, any confusing part, I can repeat. I don't have any problem.
I just need to practice more. that the Boolean algebra. It's like sometimes I forget, like when you're like simplifying or factoring out, if there's an and, do we put it as an or? Yeah, I just need to practice it.
What a second.
I was just practicing, like when you're factoring out like the operation.
Yes.
Yeah. So if you have like, sorry, let me just write this down. X, y plus x naught y. So yeah, so if you have x and y or x naught and y, do we, when we try to take out the y, right? So it would be y bracket x product of x naught.
Can you send it to me? Write in the chat.
Let me see, yeah.
Okay, so what you want to do, you want x ended with y or with x complement y. This is basically what you're talking about?
That's right. Yeah. So when we want to factor out the y, it'll be x, or sorry, it'll be y with x plus y naught. Oh, okay. Got it.
Right? Okay, here, look at this, really fun. F as a function of x, y, z equal y. Give me the sum of products. What are you gonna do?
Just y.
Somebody can tell me what should I do?
You multiply by x plus x naught.
Yes.
Yeah.
Yes, exactly. X, we said in the mean term, every single variable has to participate, right, in the term. We just have one term, and this term is missing x and z. So in that case, I have to write y, and it was x. That makes sense?
And then you just multiply it out.
Then you will exactly. So you're gonna be what? X, y, z, and then x complement y, z, then x, y, z complement, then x complement y, z complement, right? Make sense? So this is 1, 1, 1. This is 0, 1, 1. This is 1, 1, 0. This is 0, 1, 0, right? So basically, we have M7 and we have M3 and we have M6 and we have M what? 2, right? So I can come and say this table X, Y, Z, 1, 2, 3, 4, 5, 6, 7, 7, 8, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 1, 2, 3, 4, 1, 2, 3, 4, and then I come and can say M7, M6, M3, and M2, the rest are zeros. This table in front of you is equivalent to what when I say this function equal y. What do you think?
Yes, I think, yeah, I think I'm getting it better now.
Can you go up a little?
Where? El-Hadedy.
Right there's fine.
Okay, so do you have a question? By the way, this is recorded, right? So you can watch it again, right? I send you the link through the what's called through the Blackboard, so you can watch it over and over and over and over. But anyway, now you understand why we actually reverse engineering using the sum of product and product of sum. The whole entire trick for you is actually to reverse engineer something optimized to the initial values that was in the table, because the table is not actually optimized, right? Any questions? Hello. So the question now, I have a question.
Mm-hmm.
Everything is clear or not? If it's
Understanding
clear, write
it
yes.
a little bit better.
What?
I'm understanding it a little bit better.
Good. That's really good. Okay. So if it's clear to everybody, just write yes in the chat. If not, say no, so at least I can figure out what's the problem.
Professor,
Yes, sir.
can we just do a quick recap of the main topics that we went over today, just so I could study them later on?
Sure. The main topic of today, it was mean terms, max terms, and SOP and POS.
Great. So I'm looking in the book right now. Are these topics in chapter 3 of the book?
In the chapter 2.
Chapter 2. Okay, thank you.
We are very slow for a reason.
Got it.
But we're gonna move forward faster after that. But I'm very slow because it's very important. If you understand all of this, you're gonna play with them, doing combinational circuit and sequential circuit and all these things, even building processors.
Great.
Okay, if you guys don't have any questions, I would like to thank you for attending the course and attending the class today. And I wish you a best of luck and, wish a wonderful day. So please don't hesitate to ask and I will be more than happy to answer. Okay?
Professor, do you have any quiz coming up?
No. Did you see the syllabus?
I haven't checked it recently.
Yes, please. Go ahead and check the syllabus, okay?
Are we still on track to have our first midterm at the designated time on the syllabus? Are we a little
Everything's
behind?
written there, yes.
Okay.
Okay. And if it's not, just let me know and we'll discuss, okay? But I know that's written. Okay, Duke?
Oh yeah.
Yes.
Oh, but I meant, are we gonna still have our midterm on? I think it's March 7th or something. Or do you think it might be a little later, a little sooner?
No, that's fine. As much as we can cover, that's better for me.
Oh, okay, got it.
Okay.
Yep, that sounds great. Thank you, Professor.
You are welcome. So, okay, so take care, guys, and God bless you. Stay safe. Okay. Thank you.
Thank you,
You as well,
Professor.
Professor.
Thank you, Professor.
Bye. Bye.
Thank you, Professor.
Thank you, guys. Bye bye.